Hello guys, welcome to another video here on the pre-security part, and today we are currently still on the Linux Fundamentals. We are treating Linux Fundamentals part 2. So without further ado, let's dive into it. Okay, now under Linux Fundamentals part 2, we are going to continue learning our Linux journey with part 2. You'll be learning how to log in to a Linux machine using SSH, and how to advance your commands, file system interactions as well. Now we'll skip the walkthrough video and head on straight to task 1, introduction. Okay, introduction. Now welcome to the second part of the reworked Linux Fundamentals series. We'll be applying our knowledge from the first installment in the series, so I highly recommend you completing that room before proceeding further. Now, in part 2, we'll be ditching the in-browser functionality and help you get started in what is a fundamental skill in being able to log into and control the terminals of remote machines. Not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments, advancing your knowledge of the file system to perform some more useful commands, such as copying and moving files, and then introducing you to the access mechanisms in place to keep files and folders secure, and how to identify the things that our current user has access to. Now, running your first few scripts and executables. Alright, now answering the question below, let's proceed. That needs no answer, and we're done with task 1. Now, task 2, accessing your Linux machine using SSH deploy. Now, the in-browser functionality was used in Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. Okay, now in fact, the in-browser functionality use. Let me start this machine quickly and we'll continue. Now, in fact, the in-browser functionality uses the exact same protocol that we are going to be using today. Now, this protocol is called Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. Now, we will be deploying 2 machines in this room: your Linux machine and the Tryhackme attack bus. Okay, now that being said, I'm already on my Linux machine right now. Okay, so this is I'm on Linux, and then the attack box as well. So let me quickly start the attack box, and then if need be, I'll open up a terminal in my Linux. Alright, now we'll continue. What is SSH and how does it work? Now, Secure Shell, or SSH, simply is a protocol between devices in an encryption form. Now, using cryptography, any input we send in a human readable format is encrypted for traveling over a network. Now, where it is then unencrypted since once it reaches the remote machine, such as in the diagram. So my computer, hello world; the internet, encrypted; Linux server, hello world. So while it passes through the internet, it's encrypted. Now, you can learn about the various types of encryption on Tryhackme room, but for now, we only need to understand that. Now, SSH, or Secure Shell, allows us to remotely execute commands on another device remotely. Now, any data sent between the devices is encrypted when it is sent over a network such as the internet. Okay, now deploying your Linux machine. Now, press the green start machine button on the top right of this task. We've done that, and then scroll to the top of the page to see deployment informations like so. We've started the machine. Okay, we have an active machine right now, and we also have the information start box, which I already started. it's on the top. So I already started, that's why it's no longer, you can see the option again. And what else do we need? Alright, now the IP address displayed is the address of your Linux machine, this one. So this is the address of our Linux machine. Okay, we can use the attack bus here, and we can also use my Linux machine, but let's see, I probably won't use it. Alright, now let's continue. Sorry, where am I? Yes, the IP address displayed in the address of your Linux machine. The IP address displayed is the address of your Linux machine that you will be logging into using SSH. Take note of this, for example. Take note of this for now. Okay, now I'm deploying the Tryhackme attack box. Now, looking at the top of the page, press the start box. We already did button to deploy the Tryhackme attack box. That will be that we will be interacting with. Now, the Tryhackme attack box is a Ubuntu Linux machine that is hosted online in the cloud and can be interacted with via browser. You will be using this to interact with the machine that you deploy in the tags. So I don't think I need to use my machine, so we'll definitely use the Tryhackme attack box, which is ready here on the right side. Okay. Alright, now we already started the box. Now use SSH to log into your Linux machine. Now the syntax to use SSH is very simple. We only need to provide two things: the IP address of the remote machine, which we already got, the correct credentials to a valid account to log in on the remote machine. To log in with the correct credentials to a valid account to log in with on the remote machine. Alright. Now for this room, we'll be logging in as Tryhackme, and password is Tryhackme without the quotation marks. Without the quotation mark in it. Okay. Now let's use this IP address of the machine displayed in the card at the top of the room as the IP address, and this user to construct a command login in the remote machine using SSH. Let me open up your terminal quickly. Now the command is to do is SSH and then the user name of the account at the IP address of the account. Okay. Now, but first we need to open a terminal on the Tryhackme attack box we just did. There is an icon placed on the desktop named terminal. We already did, and now we can proceed to impute commands. There are two ways to open up a terminal. On the top right side here on the attack box, there is this terminal icon here. You see terminal, you can open it up from here. On the right side there are all these options here. You can see terminal, and then on the desktop page here let me minimize that. On the desktop page here you can see terminal here as well. I'm sorry. And then let's go. So for example, SSH Tryhackme, you can see it automatically fill in 10.10.94.220. That's actually our IP address, 10.94.220. Alright, now replacing the IP address with the IP address of your Linux machine, or Linux target machine. Once executed, will then be asked to trust the host and then provide a password for the Tryhackme account, which is also Tryhackme. So we'll soon do that. Now that we are connected, let's quickly do that. So we have SSH, and then the IP is 10.10.90.220, correct? Then it's supposed to be the username here, which is Tryhackme. So Tryhackme at 10.10.90.220. If we hit enter, what happens now? SSH connect to the host in port 22, no route to host. What happened? We just did it the way we're supposed to do it. It says no hosts. Let's try that again. I don't know if I did anything wrong. Okay. I tapped in the wrong. It's meant to be 94. and not 90. Okay, now the things now, yes, and it's asking for a password. The password is Tryhackme. I will type in the password. It doesn't really show that it's typing password, but it's there. So when I hit enter with Tryhackme, I think we are in. We're actually in right now. Now that we are connected, any commands that we execute will now execute on the remote machine, not our own. So if I come here now and type ls, it shows files, but not on our machine, but on the remote machine. Okay. All right. Now note, when you type a password into an SSH login prompt, there is no visible feedback, just like I mentioned earlier. You will not be able to see any text or symbols appear as you type the password. It is still working, however, so just type the password and press enter. I've logged into the Linus Fundamentals part2 machine using SSH. Yes, we've done that successfully here. Now, introduction to flags and switches. Task 3, Introduction to Flags and Switches. A majority of commands allow for arguments to be provided. Now, these arguments are identified by a hyphen and a certain keyword known as flags or switches. Now, we will later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. Now, when using a command, unless otherwise specified, it will perform its default behavior. For example, ls or listing lists the contents of the working directory. However, hidden files are not shown. We can use flags and switches to extend the behavior of commands. All right. Now I might just open another terminal for a quick do over on this so that we can understand. Okay, just a quick one, but if I go back to my original machine, let me see if I can go back from here. Yes, so I can go back within those two machines right there. Yeah. Okay, so if I normal list, this is what it gives me. We'll be back to it now. Let's quickly continue where we stopped. Now it says, when using a command, unless specified, okay, this is where I am. We can use flags or switches to extend the behaviors of commands, right? Now, using our ls example, list informs us that there is only one folder named folder 1 as highlighted in the screenshot below. Note that the content in the screenshot below are examples. I think I should just go back to the secure shell we're using. I think that's where they're using, because I already did ls and it shows my folder and unknown one. I believe. Okay, this is just a random example, so I will just continue. I'm sorry. This is a little bit slow. I don't know. Okay, so ls. So it shows us all this. So let's continue. Now, note that the contents in the screenshots below are only examples. Okay, all right. I thought it was something. However, after using the -a argument, short for --all, we now suddenly have an output with a few more files and folders, such as .hidden folder, .files, and folders with dots are hidden. So if I type in ls-a and input that, you can see more things are here available that didn't show up when we just listed just the normal ls. So we can see dots folders, and most files that are hidden always start with the dot or period. Okay, now commands that accept this will also have a --help. Now options. Now this option will list the possible options that the command accepts, provide a brief description and example of how to use it. Okay, now listing the options we can use with ls. So ls-help. So we can type in ls and then --help to actually show us the other switches or things that we can actually do with the ls command. Okay, other things that we can do with the ls command, basically, as you can see. So you can see that -a we just used here on the top. Basically, do not ignore entries starting with period and so on and so forth. Okay. All right. Now, there's also a short for this help. We can actually do ls-h, or you use -- help or -- help. So if I type in this, oh my god, it didn't recognize it. So there's no short. I thought it was -h to show you help. Okay, let me see. Okay, -h is a human readable. Okay, I thought that's a short form for help. Okay. See that some don't use it that way. Okay. All right. So the option E is in fact a formatted output of what is called the man page, short for manual, now which contains documentations for Linux commands and applications. So the man or manual page, the manual page are a great source of information for both system commands and applications available on both Linux machine, which is accessible on the machine itself and online. Now, to access this documentation, we can use the man command and then provide the command we want to read the documentations for. Now, using our example, we would use man ls to view the manual pages for ls, like so. So we have man ls or man list, and it shows the full documentation. Okay, so let's see, explore the manual page of the ls command. Let's quickly do that. I'm just going to clear this, Ctrl-L, and then I'm going to man, then ls. I'm going to type that in, and we have the full page here. We have a-all do not ignore entry starting with period, then capital letter A -- almost all, and do not list implied period and -- so on and so forth. So this is like the full manual page and the switches or flag that we can possibly use for it. For some reason I thought there was a let me see, it didn't list the help. Okay, so manual page ls1 line this to this, and press H for help or Q to exit. I'm just gonna, I thought I could do next. Okay, yes, I could. So it's really within the page. I don't know, the attack box is kind of slow today. Okay, but that's how you can explore more of the manual page of the command. So I've done that. Now, what directional arrow key would we use to navigate down the manual key? I think it's the down. I did it before. Let me quit and then start again so you see. Q. So I'm just going to go back. Manual S. Use the page down directional key, and it will keep showing you. This is line 2 and so on and so forth. If I hit it again, it will keep moving. So it's the down arrow or the page down. It's called page down. If I say down, will that work? It worked, but it can also be page down. Just the down arrow key, you keep moving down the manual page. Now, what flag would we use to display the output in a human readable form? I actually did that thinking it was help. I think it's -h, but let's see here. So let me see, -h human readable. You see, that's what I thought it was for help. So -h, and that goes it for task 3. Let's quickly go on to task 4. Here on task 4, here, good. Now, file system interaction continued. Now, we covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, we covered how to list and find the contents of folders using ls or list, and find and navigating the file system using cd. We even covered grep and so on and so forth. Now, in these tasks, we are going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders. More specifically, the following commands: command full name and purpose. Now, the first we're going to look at is touch. Touch, we use it to create a file. Make directory, we use it to create a folder. And CP we use it to copy a file or a folder. Move we use it to move a file or folder. RM we use to remove a folder or file. And then file, which is file, we use it to determine the type of file that we have. Okay, so touch or make directly to create a file or a folder. Make directly used to create a folder actually, so you can use it to create a file, so it's specific. Alright, now pro tip, similarly to using cat, we can provide full file path, that is directory 1, directory 2, node/node for all these commands. More like create a full path or do this to a particular full directory. Okay, now creating files and folders, touch and make directory. Okay, now creating files and folders on Linux is a simple process. First, we will cover creating a file, the touch command. The touch command takes exactly one argument, the name we want to give the file we create. For example, we can create the file note by using touch note. It's worth noting that touch simply creates a blank file. We would need to use commands like echo or text editors such as nano to add, or vim to add contents to this blank file. Okay, so touch note ls folder note, but there's nothing in it. And we create here and Control L, and let's create our first let's call it note 1. Enter, and then if we ls, we can see our note 1 over here. If I decide to ls note 1, you're going to find out that there's nothing. Okay, note 1, that's to list it. I mean to cut it actually. Let me see if I can cut from here. Note 1, and there's nothing inside. Okay, so let's continue. Over here we have this is a similar process for making a folder, which just involves using. Okay, this is a similar process for making a folder, which just involves using the make directory. So we just made a blank file. So making a folder, we use the make directory or the mkdir command, and again providing the name that we want to assign to the directory. For example, creating the directory, my directory, using make directory, like this, like so. So creating a new directory with mk directory. So we just do mk directory, the name of the directory or the name of the folder, ls, and you're going to see it appear here. So we're just going to mk new directory. No, not mk, please. mkdir. Okay. Oh, sorry. Make directory new dir. Enter list, and we're going to see our new directory right. Where is it? New directory, see it here. It's a folder. You can see it in blue. You can see files in white. So that's the difference. All right. Now, since we've done that and practicalized it, let's move on. Now, removing files and folders. RM. RM is extraordinary out of the commands that we have covered so far. It's extraordinarily out of the commands that we've covered so far. You can simply remove files by using RM. However, you need to provide the -r switch alongside the name of the directory you wish to remove. So RM note list is gone. Using a recursive to remove a directory, RM-b capital letter R, my directory, is to use that to remove a folder. So you can just use RM to remove a file, then RM-capital letter R to remove a directory. Okay, so let's remove all the ones we've done here. So we'll just use RM. We have RM, just simply RM note 1 is the one we have. If we do that and type in ls, we'll no longer have our notes, just like we had it here. And the next is RM-capital letter R, and then we have new dir, which is the folder I created earlier. It's done. Ls, and you find out that it no longer has the new directory folder that I created. Okay. Now, copying and moving files and folders, CP and MV. Now, copying and moving files is an important functionality on a Linux machine. Now, starting with the CP, which is copy, this command takes two arguments: the name of the existing file and the name we wish to assign to the new folder or the new file when copying. So CP copies the entire contents of the existing file, okay, into the new file. Now in this screenshot below, we are copying note to note 2. So CP note to note 2. That means ls you just find out that you have a copy of it. So folder 1 note, and then you see note 2. Note 2 is a copy of note. Don't need to practicalize that. Let's continue. Now moving a file takes 2 arguments, just like the cp command. However, that's the env we're talking about now. Rather than copying and or creating a new file, move will merge or modify the second file that we provide as an argument. Not only can you use env to move a file to a new folder, but you can also use env to rename a file or folder. So for example, in the screenshot below, we are renaming the file note 2 to be note 3. Note 3 will now have the contents of note 2. So if we move note 2 to note 3, ls, you're going to see that previously we had note and note 2. Now note 2 now becomes note 3. For me, I just feel like move is just used to rename that particular file, just like renaming. But when you say move, maybe if we type mv and then maybe dash help, let me see if there are other, if there are other ways. Dash b, let me see, f-force, do not prompt before overwriting, interactive prompt before overwrite. Let me see if there's anything special. verbose explaining what is being done, contest. I don't think there's anything special here. Alright, let's just continue. I'm just thinking out loud. Now, determining file type. This one is quite easy. So what is often misleading and often catches people out is making presumptions from files as to what their purpose or content may be. Files usually have what's known as an extension to make this easier. Okay, for example, text files usually have an extension of .txt. Yes, extensions, but this is not necessary. Now, so far the files we have used in our examples haven't had an extension. Without knowing the context of why the file is there, we don't really know its purpose. So enter the file command. This command takes in one argument. For example, we use file to confirm whether or not the note file is our examples. The note files in our examples is indeed a text file, like a file note. Okay, so if you type in file note, you get note ASCII text. Alright, just file is basically used to, let me see if there's anything here, used to confirm what kind of file is there. Let me see if there's anything in scripts or instructions. Let me see the instructions, enter. Is there nothing there? Anyways, basically you use file to know the kind of file that a file is. Alright, how would you create the file named new notes? How would I create it? I'll just create it by using touch new notes and enter. That's the correct answer. On the deployable machine, what is the file type of unknown one in Tryhackme home directory? Let's go right into that. Remember, we still have that particular machine here, so I'm going to just clear one more time, and then I'm going to list. So you can see here we have important, my file, my folder, and unknown one. So we want to know what type of file is the unknown one. So we can just type file and then unknown, complete that. If you type in enter, you see unknown one is an ASCII text. Okay, that being said, I can just paste that ASCII text. Is that correct? Okay, how would we move the file, my file, to the directory, my folder? We just use mv. Okay, now I understand. So mv, if there's already a directory, we'll just move it in. It will move in there. So mv my file, and we're just moving it to my folder. That's simple. Alright, what are the contents of these files? Okay, so they want us to see cat my folder. I'm sorry, cat, I have to type it completely. My folder 1. What am I typing? I'm sorry. I already had more of this here. Okay, so cat my folder 1. I have to go in. I think my folder 1 and there's nothing inside. Not my folder 1 actually, my folder. You should understand how I usually troubleshoot here. Sorry, let me just cd dot. Let me start again. cd dot enter ls. Let me go into the folder, my folder. I thought that's what are the contents of this file. Okay, my file that I took. I'm so sorry. Cat my file. Let me see if I can read it from there. Cat my file. Yes, so simple. I thought it was my folder actually. I'm so sorry. Okay, so that was the content. And there we go. Continue to apply your knowledge and practice the commands from this task. We'll definitely do that. We already practiced some. Now let's head on to task 5, permission 101. Okay, permission 101. Task 5, permissions 101. As you would have already found out by now, certain users cannot access certain files or folders. We have previously explored some commands that can be used to determine what access we have and where it leads us. Okay, in our previous task we learned how to extend the use of commands through flags and switches. Of course, take for example the ls command, which lists the contents of current directory. When using the -l switch, we can see 10 columns such as the screenshot below. However, we're only interested in the first 3 columns, okay, which is 1, 2, 3, which is basically, let's just start here. ls-lh. Some people use ls-la. They are different, so 1, 2, 3. So basically, let's continue. All right, now, although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what actions are allowed and what user or group has the ability to perform the given action, such as the following: read, write, execute. Read, write, and execute. Okay, we'll see more of that. Let's continue. Now, using su to switch to user 2. Let's see. Okay, let's use the cmnatic.pem file in our initial screenshot as at the top of the task. It has the dash indicator highlighting that it is a file, and then rw followed after. Okay, this is here. This is something like -rw. I don't know if they want us to go into the su file. Are we going to do that? Let's use su, then user 2, and see if it takes me anywhere. And the password should be like Tryhackme, I guess. No. I guess let's just continue. He was just trying to show us something. Let me just continue. Okay. Now, it shows the indicator highlighting that it is a file, and then rw followed after. This means that only the owner of the file can read and write this cmnatic.pem file, but cannot execute it. So rw, okay, and let's continue. I don't want to go ahead of myself. Now, briefly, the difference between users and groups. Now, we briefly explored this in Linus Fundamentals Part 1, namely the difference between a regular user and a system user. Now, the great thing about Linux is that permissions can be so granular that while a user technically owns a file, if the permissions have been set, then a group of users can also have either the same or different set of permissions in the exact same file without affecting the file owner itself. Now let's put this into a real world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers upload their own files for their website without being the web server system user, compromising the security of every other customer. So we'll learn the commands necessary to switch between users below. Okay, so I think I was getting ahead of myself. Now, switching between users. Now, switching between users on a Linux install is easy work thanks to su command, unless you are the root user or using root permissions through sudo. Then you are required to know two things to facilitate the transaction of user accounts. To facilitate the transition of user accounts. Now, the user we wish to switch to is number one, and the user's password. Now, the su command takes a couple of switches that may be of relevance to you. For example, executing a command once you log in or specifies a specific shell to use. I encourage you to read the man page for su to find out more. However, I will cover the -L or the -login switch. Now, simply by providing the -L switch to su, we will start a shell that is much more similar to the actual user logging into the system. We inherit a lot more properties of the new user, that is environment, variables, and the likes. Okay, so su user2, just an example. For example, when using su to switch to user2, our new section drops us into a previous user's home directory. pwd. We are now, after using -L, our new section has dropped us into a home directly of user 2 automatically. Okay. Oh, let's see that again. So, for example, when using su to switch to user2, our new section drops us into our previous user's home directory. Su -L user2, and this drops us into user2 at Linux2 pwd home user2. Okay. Compared to previously, what happened when they used only su? When they used only su, it gave us user2. It's the same thing. Okay. All right. Now, on this deployable machine, who is the owner or who is the owner of importance? On a deployable machine, who is the owner of importance? Is that not root? I'm sorry, I didn't get the question. On the deployable machine, who is the owner of importance? On the deployable machine, who is the owner of user2? I'm so sorry, I get it now. I think it was basically from the practical we just did. The owner of the owner here, like the owner of importance is user2. What would the command command be to switch the user2? Just su user2. I'm so sorry. User2. Okay. Now switch the user2 using the password user2. Okay, guess what I've been trying to do since. Let me see. pwd, we have home Tryhackme. I'm just going to user2 and I'll stop that. Let me quit. I want to quit. Okay, so why I quit? Because I want to use the -L. So we have su -L, and that should be user2. And access me for password, and we have user2. And there we go. If you put pw print our working directory, you'll see home user2. Okay, great. Now I've done that. Output the content of important. What is the flag? So let's list what is inside here. what is here? Let's see, ls -la. Okay, honestly I'm just gonna hold on here and see. Okay, I think I'm back to user 2. Let's go back to Tryhackme. cd Tryhackme and ls. And okay, this is what they're asking for. Important. It was in the folder, on the normal folder here, so that took me like ages. Important. And we have Tryhackme to user 2. All right, I'm still learning, please. Okay, now output the content of the important. We've done that, and we're successfully going into task 6. For task 6, all right, task 6, common directories /etc. The root directory is one of the most important root directories on your system. The etc folder, short for etc. is a common place location to store system files that are used by your operating system. For example, the sudoers for the main users file highlighted in the screenshot below contains a list of the users and groups that have permission to run sudo or set of commands as the root user. Okay, now also highlighted below are the passwords, passwd or password, and shadow files. These two files are special for Linux as they show how your system stores the password for each user in encrypted format called the SHA-512. Okay, so on the Linux 2 etc $list, if you go into the etc file, okay, let me clear this and ls and let's see. If you have ls-lh, do you have etc files here? No. Okay, so this is just an example. Okay, now /var, the var directory with var being short for variable data is one of the main root folders found on the Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. Now, for example, log files from running services and applications are written here, var /log, or other data that is not necessarily associated with a specific user, that is database and the like. So if you var list, you'll be able to see backup var. Let me see, /var with that show, and then the $sign. That's yes. Let me see. Yeah, I knew it. That's why. Okay. Alright, this is just an example. So roots, let's go into the root. Unlike the home directory, the root folder is actually the home of the root, the home for the root system user. There isn't anything more to this folder other than just understanding that this is the home directory for the root user, but it is what it mentioned, as the logical presumption is that this user would have their data in a directory such as home /root by default. Okay, ls, and you see everything just like we did here. /tmp, this is a unique root directory found on a Linux install, short for temporary. Okay, temporary. That's it. Okay, now the tmp directory is volatile and is used to store data that is only needed to be accessed once or twice, similar to the memory on your computer. Once the computer is restarted, the contents of this folder are cleared out. What's useful for us is in pen testing is that any user can write to this folder by default, meaning once we have access to a machine, it serves us a good place to store things like our enumeration scripts. Okay, temp ls, you see some other things here. Readme, we've done that. What is the directory path that we expect logs to be stored in? As you be var /log. Okay, and what root directory is similar to how RAM on a computer works? That should be temp, or like temporary. Okay, and name the home directory of the root user. It should be root. And lastly, now apply our learning and navigation through these directories on a deployed Linux machine. We'll do that. Okay. Conclusions. Nice work. This room was quite theory dash heavy and covered quite a range of fundamentals in getting you familiar with Linux. To quickly recap, this room taught you how to connect to a Linux machine remotely using SSH, secure shell, advancing your use of commands by providing flags, switches, where you can go to learn about this for each command, the man page. Okay, some more commands that you would frequently be using to interact with the file system and its contents, like move, copy, and the rest. A brief introduction to file permissions and switching user, the SU. Now, a summary paragraph of the important root directories on Ubuntu Linux installed and how we may be able to use this data stored, use the data that is stored within this. Okay, be able to use the data stored within this. Okay, I encourage you to go through this room once or twice. It's my second time, to gain some familiarity with the concepts. After all, practice makes perfect. That's correct. Answer the question, proceed to the next task to continue your learning. Completed. And lastly, task 8, visit part 3 of the Linus Fundamentals series. We're going to do that next, and then answer the questions below. Terminate the machine we just did and completed, and join the Linux Fundamental part 3. Great. Thank you for learning with me in this room. We're going to the Linux Fundamentals part 3. That's the last room for the Linux Fundamentals. And thank you for studying with me. Thank you for learning with me. Have a good day and ciao.